It's your dream catcher. Today we are going to discuss ray optics and optical instruments. So the focus area topics are reflection of light by spherical mirror, then refraction at spherical surface and by lenses, then refraction through a prism, then microscope. Okay, the next topic is non-focus area important topics. The TIR, total internal reflection and its application, dispersion and its application, scattering of light and its application, telescope. Law of reflection of light. The incident ray, reflected ray, normal lies in the same plane. Second one, the angle of incidence is equal to angle of reflection. Incident ray, normal, refracted ray, mirror. Then according to Cartesian sign convention, all the distance are measured from pole of the mirror and all distance measured in the direction of incident ray are taken as positive. Height measured perpendicular to principal axis and upwards are taken as positive. The light goes like this, it's positive. If it goes like this, it is negative. If it goes like this, it's positive, it's negative. This is positive. Spherical mirrors are of two types, concave mirror and convex mirror, and the focus area of a principal spherical mirror. Concave mirror, the light ray which are coming parallel to the principal axis after reflection converges to a point on the principal axis, and this point is called principal focus of a concave mirror. A ray of light which are parallel to the principal axis after reflection will converges to a point, and that point is known as principal focus. Then convex mirror, a light ray which are coming parallel to the principal axis after reflection from a convex mirror appears to diverge from a point on the principal axis on the other side of the mirror, and this point is called principal focus of a convex mirror. A ray parallel to the principal axis after reflection from a convex mirror, it diverges on the principal axis Okay, this is the principal focus. So the relation between R and F, we know R is equal to F. To find that, we have to take two rays, one which passes through the passes parallel to the principal axis and goes to the principal focus, and the other is which passes through the center of curvature. We should take tan theta. Tan theta then tan 2 theta. Since theta and 2 theta are very small, we can take theta is equal to and tan theta is equal to. No need for adding tan. So just divide, or that's when you get the value 1 by 2 is equal to f by r. So 2f is equal to r. Okay. Mirror formula. For mirror formula, you have to take three rays. One which passes through the parallel to the principal axis and moves towards the focus, and another principal, that is the pole, then reflects, and only two. One was also there. I think it was. For now, here only two rays I took, and in the triangle, we have to consider two sets of triangle. Okay. These are the triangle, and at last you will get the value as on taking two triangles, then what? Then substituting the value, at last you will get 1 by v plus 1 by u is equal to 1 by f. Okay. Then magnification, m is equal to minus v by u. Refraction means this is a plane. If the light rays come from a rarer medium to the denser medium, it bends towards the normal, and if the light ray comes from the denser medium to rarer medium, the light ray bend away. The first case bend towards a normal, and second case bend away from the normal. And the refraction, the direction of propagation of obliquely incident ray of light that entered to the other medium changes at the interface of two medium. When the light ray the incident light ray, when travel from one medium to another, will change at the interface of the two medium. And the refractive index, n is equal to c by v. A refractive index of a medium is defined as the ratio of velocity of light vacuum to the velocity of light in the medium. Ratio of velocity of light in vacuum to the velocity of light in the medium. And laws of refraction. Incident ray, refracted ray, normal to the point of incidence lies in the same place. Refracted ray, okay. Then the ratio of sine of angle of incident to sine of angle of refraction is a constant. Refraction through a glass slab. Okay. Glass slab. Rarer to denser medium, bend towards a normal. Denser medium to rarer medium, bend away from the normal. Just draw a straight line. Okay. The sunrise and delayed sunset. Early sunrise, delayed sunset. The density of air in the atmosphere, density of air continuously decreases. Therefore, the light coming from sun is traveling from a rarer medium to denser medium. Therefore, it bends towards a normal. Thus, we see the sun at an apparent position raised above the horizon. For example, this is a pond and here is a fish. This is rarer medium and this is denser medium. When a man is looking, the fish seem to be little bit elevated. Okay. Towards normal. So, and at the same kind, when the fish is looking the man, he seems to be a very giant person. And what I have to say is that when we go look from rarer medium, means the denser medium to rarer medium, the sun is at an apparent position just raised above the horizon. In an apparent position, it's a little raised, so that the density of air in the atmosphere continuously decreases. Therefore, the light coming from the sun is traveling from rarer medium to denser medium. Okay. Therefore, it bends towards normal. Apparent position raised above the horizon. Twinkling of the stars. The density of air in the atmosphere continuously decreases. The density of air in the atmosphere, therefore the light coming from star is traveling from rarer medium to denser medium. Therefore it bends towards a normal. Thus we see the star at an apparent position, but the density of air in the atmosphere continuously changes. Therefore, the apparent position also continuously changes. Thus, the star appears to be twinkling. When we look from the denser medium to rarer medium, like the fish is looking at the man, he seems to be very large. Likewise, we also, when we look, it seems to be little elevated. Yeah. Apparent depth, this is what I have said now. Refraction at spherical surface. The closed surface formula, curved, it's little curved surface formula, n2 by v minus n1 by u is equal to n2 minus n1 by r. Lens maker's formula. 1 by v minus 1 by u is equal to n2 minus n1 divided by n1 in bracket 1 by r1 minus 1 by r2. Lens maker's formula. 1 by v minus 1 by u is equal to 1 by f. The power of a lens is the reciprocal of focal length expressed in meter, and the SI unit of the power of lens is diopter. P is equal to 1 by f. And then the combination of two thin lenses, f is equal to f1 into f2 divided by f1 plus f2. Effective focal length 1 by f is equal to 1 by F1 plus 1 by F2 plus 1 by F3 and goes on. And the effective power P is equal to P1 plus P2 plus P3. And the effective magnification M is equal to M1 into M2 into M3. Prism. Then the refraction through a prism. Take the triangle AQNR. Here angle Q plus angle R is equal to 180. Angle A plus angle N is equal to 180. Okay, it's a quadrilateral. In triangle QNR, R1 plus R2 plus angle N is equal to 180. From 1 and 2, R1 plus R2 is equal to angle A. And in triangle QMR, I1 minus R1 plus I2 minus R2. And the next step, I1 plus I2 minus R1 plus R2. At last, we'll get this formula. The closest comfortable distance for viewing the image is when it is at the nearer point. It causes some strain on the eyes, therefore the image formed at infinity is often considered more suitable for viewing by the relaxed eye. M is equal to 1 plus D by F. Nature. Limitation of simple microscope. If you know the answer, comment this answer in the comment box or just ask me. This is the total internal reflection. Okay. When light travels from the denser medium to rarer medium, the refracted ray bends away from the normal. As the angle of incidence increases, the angle of refraction also increases. For particular angle of incidence, the angle of refraction becomes 90 degree. This angle of incidence is known as critical angle. Okay. Total internal reflection. When light ray travel from denser medium to rarer medium, if the angle of incidence is greater than the critical angle, it gets totally reflected into the same medium, and this phenomena is called total internal reflection. We'll draw. Okay. Application of TIR, that is the total internal reflection. First one is mirage. In hot sunny day, the layer of air in contact with sand in the desert become hot and rare. upper side are comparatively cooler and denser. Therefore, the ray of light coming down from a distant object, like a tree, is traveling from denser medium to rarer medium, and it suffers total internal reflection. Total internal reflection means what? The angle of incidence should be greater than the critical angle. Thus, for an observer, the image of the distant object is seen inverted. This makes the illusion that the tree is standing near the pool of water. Thus, the phenomena is called mirage. Okay. In the lower side is hot and upper side is cooler and denser. Here total internal reflection takes place, so that a person standing far away thinks that the tree is near a pond, and this phenomena is called mirage. Brilliance of diamond. The refractive index of diamond is very high, that is 2.42, and the critical angle is very low, 24.4 degree. Moreover, the face of diamond are cut in such a way that the ray entering the diamond undergo multiple internal reflection inside it and finally comes out through few face. It tells that the diamond is built in such a way that when a light entering the diamond get reflected multiple times, and the light can only go outside through little small number of phases, so these phases appear glittering. Optical fiber. The core of optical fiber is made up of glass or quartz. N is equal to 1 by 7. There is a thin layer of outer covering called a cladding. The cladding is made up of a material of low refractive index. N is equal to 1.5. The core of a optical fiber is made up of a glass or quartz, and there is a thin outer covering called a cladding. The cladding is made up of a material of lower refractive index. When the ray of light enters the fiber at one end, it undergo multiple total internal reflection. Okay. The light entering at one end undergoes multiple internal reflection and goes out through another way. And this outer layer is made up of cladding. Here the refractive index is 1.7 and this is 1.45, so it is less. Dispersion. The phenomena of splitting of composite light into its component colors is called dispersion. The dispersion takes place through the refractive index of a medium is different for different wavelength, that is a color. The refractive index is inversely proportional to wavelength of light. Therefore, the violet light deviates more than red light. Dispersion. The phenomena of splitting of composite light into its component colors is known as dispersion. The dispersion takes place through refractive index. Refractive indexes of medium is different from the different wavelength. Violet light deviate more than red light. Now we have to talk about the rainbow. The rainbow is formed due to the combined effect of dispersion, refraction and total internal reflection of sunlight by the drop. The condition for observing a rainbow is that the sun should be shining in any part of the sky while it is raining. What is this? In one side, the sun should be shining, and in the other side, it should be raining. An observer can therefore see a rainbow only when his back is towards the sun. Okay, here sun, rain, we looking at there. The rainbow is of two types, primary rainbow and secondary rainbow. The three-step process is refraction, total internal reflection and refraction. Dispersion is there, okay, dispersion. The three-step process. I'll check that and I'll comment that in the comment box. Secondary include, okay, refraction itself. I think it's refraction itself in the third three-step process. First is refraction, total internal reflection, total internal reflection, then refraction. Scattering of light, the irregular and partial reflection of light at the dust particle and air molecule in the atmosphere is called scattering. The irregular and partial reflection of light at the dust particle and air molecule in the atmosphere is called scattering. The intensity of scattered light is inversely proportional to fourth power of wavelength. Then the blue color of sky. When sunlight comes through the atmosphere, it undergoes scattering of dust particle and air molecule. Thus, the low wavelength region is more scattered. Since our eyes are more sensitive to blue than violet, the sky appears blue. Read that once more. The red color of the sun at sunset and sunrise. More distance through the atmosphere, most part of the low wavelength region is scattered away and leaves scattered longer wavelength region. Okay. Away. So the red is the most part of low wavelength region is scattered away and the least scattered longer wavelength region reaches our eyes. White color of clouds. So the previous thing was red deviate more because the wavelength is less, So our eyes can see red color which appears far away from us. The white color of the cloud. The large scattering object. That is not true. All wavelengths are scattered nearly equally. Thus, clouds are droplet of water, A, which is greater than lambda, as size of the molecules are generally white. And then about optical instrument, first one eye, then the defect of eye. The defect of eye include presbyopia. The least distant of distinct vision increases with age because decreasing effectiveness of ciliary muscle and loss of flexibility of lens. Book at about 25 centimeter. The image appears blurred. This is due to the increasing in the age, mainly the decreasing the effectiveness of the ciliary muscles and the loss of flexibility in the lungs. It is corrected by using converging lens. Myopia. Light from a distant object arriving at eye lens can be converged at a point in front of the retina. Nearsightedness. Use a concave lens. Hypermetropia. Comment that whether are you facing myopia or hypermetropia, A or B. Astigmatism occur when the cornea is not spherical in shape. Corrected by cylindrical lens. Then about telescope. The final image is enlarged, inverted and virtual. M is equal to F0 by Fe. The above equation shows that to have greater magnification for the lens telescope, the total focal length of the objective should be larger and that of the eyes should be small. The length of the telescope is a separation between objective lens and eyepiece. The above equation shows to have greater magnification for telescope. Learn this formula. Okay, so we have discussed many things. Yeah, we have discussed 68 pages beautifully. Just go through all these pages. I said to go in the sense just to recollect things. That's it. I hope that I was able to complete all these important topics of non-focus area, total internal reflection, dispersion and its application, scattering of light, and telescope. Then focus area topics: the reflection of light by spherical mirror, refraction, refraction through a prism, then refraction at spherical surface and by lens, and then the microscope. Yeah. All these 9 topics are very important topics. So I think it's time to leave. Thank you and have a nice day. So your homework is to recollect and write the points which I have taught you today. Thank you.